Good evening, my geometry students. Today we're going to be looking at some different angle relationships. You have learned about angle relationships in the past when you learned about supplementary, complementary, vertical, and adjacent angles. So we have a few more that we're going to learn now in geometry. So to get started, first let's write down what the definition of the transversal is. And that is a line that intersects two or more coplanar lines at distinct points. The word coplanar just means that the lines are in the same plane. Now, we see that our transversal is that red line, and it's intersecting the two other lines at one distinct point, creating 8 angles in this picture. Alternate interior angles are non-adjacent interior angles, so they're not next to each other, and they lie on opposite sides of the transversal. So 4 and 5 would be an example of alternate interior angles. Also 3 and 6 would be another example. Next, we have same side interior angles. So again, when we mean interior, we want to see between the two lines in the plane. And we're looking at the inside of those lines. So we would say 4 and 6 would be same side interior angles, and then another example would be 5 and 3 would be same side interior angles. Corresponding angles lie on the same side of the transversal T and in corresponding positions. So if we went through and kind of broke that up, and let's say I'm just going to cover this. No. Alright, there we go. So we broke it up. So let's just say that we have two intersecting lines. So we broke up the transversal. We see that 1 and 5 are going to be in the same position. 2 and 6 would be in the same position. 3 and 7 would be in the same position, and then 4 and 8 are in the same position. So those are called corresponding angles. Now, alternate exterior. So when we talk about exterior versus interior, we know exterior are going to be on the outside. So non-adjacent exterior angles that lie on opposite sides of the transversal. So we have 1 and 8 are an example, and then we could also say 7 and 2 are alternate exterior angles. Now, some angle relationships may be used when proving two lines intersected by a transversal are parallel. So first, let's start with the corresponding angle postulate. That states that if a transversal intersects two parallel lines, then corresponding angles are congruent. So if line M and line N are parallel, we know angle 1 and angle 5 would be congruent. They're corresponding. So let's say if angle 1 is 120 degrees, then we know that angle 5 has to be 120 degrees. Now, another example of corresponding angles would be 2 and 6. So let's say if 2 then would be 60 degrees, because we know angle 1 and angle 2 are supplementary angles, then if angle 2 is 60, angle 6 also has to be 60. We could go a step further and say, well, if we know angle 2 and angle 3 are vertical angles, so angle 3 has to also be 60 degrees. So then by the corresponding angle postulate, angle 7 also has to be 60 degrees. So then we know 3 and 7 are congruent, and then angle 4 and angle 8 would also be congruent. Next, why don't you try this one on your own? So which angles measure to 55 degrees using your corresponding angle postulate? Now we're going to look at the alternate interior angle theorem. So we know that that is if a transversal intersects two parallel lines, then alternate interior angles are congruent. So we can look down here, we know angle 4 and angle 5 are alternate interior angles. They're inside between the two lines and then on opposite sides. So if angle 4, we'll say, is 110 degrees, then we know that angle 5 is also going to have to be 110 degrees. So another pair of alternate interior angles are 3 and 6. So this would have to make, we'll say angle 3 is 70 degrees because angle 3 and angle 4 are supplementary. So then if angle 3 is 70, we know that angle 6 corresponds to that and is going to be congruent, so it's also 70 degrees. Now we have same side interior angles. Now if you look at same side, so an example of that is going to be angle 4 and angle 6 are alternate interior angles. So that says that if the transversal intersects two parallel lines, then same side interior angles are supplementary. So they would add up to 180 degrees. So same thing over here. Angle 3 and angle 5 are same side interior angles. So the sum of those two angles is 180 degrees. Now we also have the alternate exterior angles theorem. So if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So we know line M and line N are parallel. So then alternate exterior, that's going to be angle 1 and angle 8, and they are congruent. So if angle 1 is 100 degrees, then we know angle 8 is congruent, so it also has to equal 100 degrees. Then another example would be 2 and 7 are alternate exterior angles. So this is the case, angle 2 would have to equal 80 degrees. So then angle 7 is congruent, so that also has to be 80 degrees. Alright, try this one on your own. So finding measures of angles. So what are the measures of angles 3 and 4? Which theorem or postulate justifies each answer? So write how many degrees the angle is, and then which theorem is going to prove that, justify that.